25G PON is the future of fiber optic networks. It offers significant speed improvements over previous generations of PONs, and it can support a wide range of applications. If you're looking for the fastest and most reliable broadband connection available, then 25G PON is the way to go. Hi everyone, and welcome to Learn to Profit. Today, we're going to talk about the 25G PON, the next generation of PON technology. PON stands for Passive Optical Network, and it's a type of fiber optic network that uses a single fiber to connect multiple users to a central office. This is in contrast to point-to-point fiber optic networks, which use a separate fiber for each user. PONs are more efficient and cost-effective than point-to-point networks, and they're becoming increasingly popular for broadband access. Fundamentals of 25G PON. 25G PON is based on a technology called wavelength division multiplexing, WDM. WDM allows multiple wavelengths of light to be transmitted on a single fiber optic cable. This allows 25G PON to deliver high speeds to multiple users without the need for additional fiber. 25G PON also uses a new type of optical fiber called G .654 E-grade fiber. G .654 E-grade fiber has lower attenuation than traditional optical fiber, which means that it can transmit signals longer distances without losing signal strength. Concepts of 25G PON. 25G PON uses a number of new concepts and technologies to deliver its high speeds. One of these concepts is called Nyquist subcarriers. Nyquist subcarriers are a way of dividing the available bandwidth into smaller channels. This allows 25G PON to deliver more data over a single fiber. Another new concept in 25G PON is called polarization division multiplexing, PDM. PDM allows two independent signals to be transmitted on a single fiber optic cable. This doubles the available bandwidth on a single fiber. 25G PON architecture and principles. The 25G PON architecture is similar to previous generations of PONs. There is a central office, CO, that is connected to multiple optical network units, ONUs, using a single fiber optic cable. The ONUs are located at the customer premises and provide the connection to the end user. The CO is equipped with an optical line terminal, OLT, which is responsible for managing the PON network. The OLT sends and receives data from the ONUs. The ONUs are equipped with optical network terminals, ONTs, which are responsible for connecting the end user to the PON network. The ONTs convert the optical signals from the OLT into electrical signals that can be used by the end user's devices. Benefits of 25G PON. 25G PON offers a number of benefits over previous generations of PONs. Higher speeds. 25G PON can deliver up to 25 gigabits per second of symmetrical bandwidth, which is enough to support even the most demanding applications. Lower latency. 25G PON has lower latency than previous generations of PONs, which means that data can be transmitted faster. Increased capacity. 25G PON can support more users and more traffic than previous generations of PONs. Reduced costs. 25G PON is more efficient than previous generations of PONs, which can lead to lower costs for service providers. Applications of 25G PON. 25G PON is ideal for a variety of applications, including broadband access. 25G PON can provide ultra-fast broadband access to homes and businesses. 5G transport. 25G PON can be used to transport 5G traffic from the base station to the core network. Enterprise services. 25G PON can be used to deliver high-bandwidth services to businesses, such as cloud computing and data center connectivity. The wavelengths used for RX and TX in 25G PON are 1310 nanometers and 1270 nanometers, respectively. The technology used for upstream and downstream in 25G PON is wavelength division multiplexing, WDM. If you enjoyed this video, be sure to like and subscribe to the channel for more videos about fiber optic networks and other technologies. You can also hit the bell icon to be notified when we upload new videos. Thanks for watching.